Hi everyone, today let's go over the 2005 AIME I problem 15. The problem reads, triangle ABC has BC equals to 20. The incircle of the triangle evenly trisects the median AD. If the area of the triangle is m root n, where m and n are integers and n is not divisible by the square of a prime, find m plus n. So, when we see a geometry diagram, the AIME, and it's at problem 15 with such a short sentence as our problem statement, we always try to draw a really good diagram. So let's try to draw this triangle. And here. And say that this is the median. Okay, and now let's draw the incircle. I guess that'll do for now. Okay, and now we label the points. This is A, B, C, and this is D. Let's connect this. Okay, since the median trisects the incircle, then since all of these are equal, let's let each of them be equal to x. So what we can do now is we can let this point be called E, this point be called F, and let's let this point be called T. Well, the first thing we can notice is that AE and AEF are equal, right? They're not equal to x though. They're equal because power of a point and equal tangents to the circle. But also notice that AE squared times equals AF squared. It's also equal to, also by power of a point, this length and this length multiplied, right? Also by power of a point. So what we can do is we can write it as 2x times x. But now notice that we have 2x times x here too, right? And so that means that our length over here, dt, will also be equal to this. It's equal to dt squared, which means that AE equals AF equals dt equals x root 2, since we took the square root of this. So we can write that in on our diagram. But something else we can notice is that since BF is equal to BT by equal tangents again to the circle, that means that DB is equal to this length, DB is equal to AB. And we know that DB is equal to half of BC since D is the median. So DB equals 20 over 2 equals 10, which means that AB is also equal to 10. Okay, now let's try to find the length of AC. Since DC is also equal to 10, that means that CT is equal to 10 plus x root 2, which means that CE by equal tangents will be also equal to 10 plus x root 2. So this part's going to be 10 plus x root 2. Now we can apply something called Stewart's theorem. Stewart's theorem is, let's give you an example of this. So if I have a triangle A, B, and C, A, B, C, and if I have a line down the middle here, we can relate all the side lines in here. If we let this be B, this be M, this be N, and this is C, and BC is equal to A, and let's call this D, AD equal to D, then we know that the relation will be B times M times B plus C times N plus C is equal to M times A times N plus D times A times D. The reason why I wrote it like this is because we can remember this easily as a man and his dad put a bomb in a sink. And that's how I remember Stewart's theorem. So now we can apply this to the triangle up here on AB, ABC, and because we can find AD using this formula. So what we will get is, here, let me move this down so we can see. If I select all of this. Okay. Now, if we can try to use Stewart's theorem now. So let's write it in terms of side lengths. We will find that it's AB squared, which was the C in our original equation, which is AB now. AB squared times 10 plus AC squared times 10 is equal to 10 times 10 times 20, because we're doing the BD, DC, and then the whole BC, plus DAD, which is 20 times 3x squared. And this will give us AB squared plus AC squared is equal to 200 plus 18x squared, because we just divided both sides by 10 and simplified. And now what we can do is we can write AB out. What is AB? AB is 10, right? Yeah, so that's going to be 100 plus AC is equal to 10 plus x root 2, which is the CE plus AE, plus x root 2 is equal to 10 plus 2x root 2, which is equal to 10 plus 2x root 2 squared is equal to 200 plus 18x squared. And now we can just solve this easily, right? This gives us 18x squared plus 100 is equal to 100 plus 40x root 2 plus 8x squared. And now we can have some fun. We can cancel out the hundreds on both sides. And then we can simplify this 10x squared plus minus 40x root 2 is equal to 0. So x squared minus 4x root 2 is equal to 0. And x is equal to either 0 or 4 root 2. But x cannot be equal to 0, because then that just gives us a point in space. So x is equal to 4 root 2. And now that we know all the side lengths now. We know that AB equals 10 from before, since it's equal to BD, AB. BC is equal to 20. BC is equal to 20 from the problem statement. And AC is equal to, from here, AC is equal to 10 plus 2x root 2. So 10 plus 2x root 2 is equal to 10 times 10 plus 2 root 2 times 4 root 2 is equal to 10 times 6 plus 16 is equal to 26. So now the problem is just finding the area of a 10, 20, 26 triangle. Okay. And we can use Heron's formula. So Heron's formula states that the area of ABC is equal to the semiperimeter times the semiperimeter minus all three sides. Okay. And the semiperimeter is just half of the perimeter, so it's 10 plus 20 plus 26 over 2, which is equal to 28. And now applying this, we get the answer will be the square root of 28 times 28 minus 10, which is 18, 28 minus 20, which is 8, and 28 minus 26, which is 2. And this just gives us 4 on the outside, so 4 root 28 times 18. And 28 is equal to 7 times 4. 18 is equal to 9 times 2, which gives us 4 times 2 times 3, the square root of 14, which is equal to 24 root 14. And that is our final answer. But by the answer extraction, we need to add both of them. So we get our answer of 24 plus 14 equals 38.